Okay, so on this question, we've got two forces of magnitudes. Oops, I didn't mean to do that. Let's undo that. I'm just going to get that arrow ready again. We've got two forces of magnitudes of 2 newtons and 5 newtons acting on particle direction shown. Calculate the magnitude of the resultant force. Now, the easiest way to do resultant force in this type of question is to take this force and put it on the end, because the resultant force is what happens when you combine these two forces. And if you think of these two forces as vectors, then what you can do is you can add them up by putting one on the end of the other one. So this is our resultant here. So therefore, r squared will be equal to 2 squared plus, that should be an equal sign, sorry. R squared will equal 2 squared plus 5 squared minus 2 times 5 times cos of 140. How do I know it's cos of 140? Well, this angle here is 40 from here, and therefore this angle is 140, and we've got the cosine rule here. Okay, so I jumped into the cosine rule without explaining where I got my angles from. So we simplify that and we get 44.32. So therefore R will equal 6.66 newtons to 3 significant figures. Now, to calculate the angle between this resultant force R and the magnitude of 5 newtons, so here's theta, that's the angle we're going to look at. We're going to use the sine rule. So we know that sine theta over 2, because this length is 2 and this is opposite this angle, will equal sine of 140 over R, which was well, it's actually not 6.66, it's 6.657 and so on. You should use the full number here, even though we've rounded here, okay, when working out next values. Rearrange that, so work that out, times by 2, inverse sine, intermediate piece of working, I think you get sine theta is equal to 0.193, theta comes out to be 11.1 degrees. Any questions in the class? Okay, so our next question is going to be a 7 marker. So here we go, 7 minutes to do the next question. Okay, this question is a little bit more demanding than the first question. So we're going to look at a body of mass 20 kilograms is sitting on a rough plane, so we've got 20g acting down. Angled at alpha to the horizontal, the body is held at rest on the plane by an action of force of p newtons acting up the plane. We therefore will have also a normal reaction against the plane. The coefficient of friction between the body and the plane is mu. When p is equal to 100, the body is on the point of sliding down the plane, so therefore friction will act up the plane. And we know that p is equal to 100 in this case. So first thing we're going to do, we're on the point of sliding down the plane, so we are in equilibrium, so there's no acceleration. So we can resolve perpendicular and parallel and know that all the forces on one side equal the forces on the other side. If we drop a perpendicular down here, we can see that that's 90 minus alpha and this is alpha. So this distance will be 20, this component of this force will be 20g cos alpha. So let's put 20g cos alpha there. And there's nothing else acting on this side, so on the other side that's just going to be equal to r. Now we know that the friction equals mu r, so the friction will equal mu times by r, which is 20g cos alpha. Now we resolve parallel to the plane. Okay, so we've got p plus fr going up the plane. And then down the plane is this component of the 20g, which is the sine alpha component. So it's going to be equal to 20g sine alpha. So let's put that all in. We know that p is equal to 100. We know fr equals mu times 20g cos alpha. Okay, this is equal to this. And we got 20g sine alpha on this side. Now if we divide throughout by 20, we get 5 plus what's it going to be? G mu cos alpha is equal to g sine alpha. So we've proven what they want in part A. So this is our part A. Part B. When p is increased to 150, the body's on the point of sliding up the plane. So it's on the point of sliding up the plane. I'm going to change my diagram now. And I'm going to put my friction in the opposite direction. And my p is now 150. Let's just actually rub that out and put 150 in there. So here's my new diagram, given that it's on the point of sliding up the plane. So the perpendicular part is going to be exactly the same. So there's no change to this. So equation 1 won't change. So let's just resolve parallel to the plane. Resolve, I spelled that wrong, didn't I? Let's resolve parallel to the plane again. And we're going to have P. And this time we've got FR in the other direction. And we've also still got the 20 sine G sine alpha. Okay. So from this we know that FR is going to be equal to mu 20g cos alpha, because that didn't change in equation 1. So we got 150, because P is 150, is equal to FR, which is 20g sine, no, cos alpha, sorry. Okay, so we've got FR is equal to 20g, I'm going to put the mu in, which I've also forgotten. So let's chuck that in there. Plus 20g sine alpha. Now, if we want to try and get this all in terms of alpha and g, we need to do something about this cos alpha and this is sine alpha. Well, we know from here that mu g cos alpha, okay, is equal to g sine alpha. If we take this 5 to the other side, let's just write it in a different colour. So we've got g mu cos alpha will equal g sine alpha minus 5. So we can just substitute this straight in. Let me just think. I'm just trying to look at colours. I've got roughly yellow. It's almost the same. It's just a difference of 20. So just go times that by 20. So we get 150 will equal 20 times this gm cos alpha. There's gm cos alpha. So we're going to replace that with g not G mu, sorry. So we can replace that with G sine alpha minus 5. Add on the 20 G sine alpha. So let's just create a little bit more space for me to finish this off. There we go. And where are we up to now? So we can cancel out some zeros to just make it a little bit simpler. So we get 15 equals, we've got 2G sine alpha plus another 2G sine alpha will give me 4G sine alpha. And we've got 2 times minus 5, which will give me minus 10. So 25 will equal 4G sine alpha. So sine alpha, if I put it on this side, will equal 25 divided by the 4G. And then we just finish that off by doing inverse sine. Let's just make that nice and clean. Finish off this answer. Alpha equals inverse sine of 25 over 4G. Go back, let's just refer back to the question, make sure we've answered it. We want an expression for alpha in terms of G, which we've done. We've got alpha in terms of G. Any questions in the class? Cool, right. So our next question is, I think, is it a 4 marker? 5 marker. Our next question is a 5 marker. So let's give you 5 minutes to do this question here. Okay, missed the end of that one. So here we go. We've got a diagram that shows a velocity time graph for a train travelling on a straight level track between stations A and B from here to here. They're 2 kilometres apart. The train leaves A accelerating uniformly from rest for 400 metres. So this being a velocity time graph, the area under this is equal to 400. Okay, until reaching a speed of 32 metres per second. So we can find the time for this bit straight off the bat by just doing 400 divided by 32 and then times by 2, and you get the time here. Remembering the area of a triangle is equal to half base times height. So half of 32 times whatever this equals is 400. So you divide by 32 and times by 2, you'll get this distance here is 25. Next bit. The train travels at this steady speed for t seconds before deaccelerating uniformly at 1.6 meters per second. So the gradient here is minus 1.6. So we know that this is 32. So if we do 32 divided by 1.6, we get this distance here, which is 20. Okay, so 32 divided by 20 must equal 1.6. So therefore, or minus 32 divided by 20 is minus 1.6. If we do the 32 divided by 1.6, we get the 20. So multiply these two together, we get the and times by half, we get 320, which is the distance under this part of the graph. Remember, area is equal to the distance under velocity time graph, so 32 times 20 times by half will give me the area under here, which will give me the distance. So therefore, the total distance that remains in the middle here is going to be 2,000 minus 400 minus 320, which comes out to be 1280. So therefore, the time taken here will be 1280 divided by 32, which comes out to be 40. So therefore, the total time for our journey is going to be 25 plus 40 plus 20, which gives me 85 seconds. Any questions in my class? Nope. Right, this next question. If you can pull this one off in 8 minutes, you are doing very well. Nasty simultaneous equation moments question coming up. 8-minute question starting now. Just in case you're struggling to read them, that should be a third just there, and that should be a half just there. Okay, so coefficient of friction between ladder and wall is a third. Coefficient between ladder and the ground is a half. Okay, you've seen how tricky that is to get out in 8 minutes. If you got that out, well done. That's quite impressive if you have. We'll see why this is so tricky to get out in 8 minutes in a minute. So I'm just going to put, I pre-drew these just to save myself some time when writing this out. So that's going to be my X and that's going to be my 3.5. If I have my, what was it? That's the ladder weight because it's halfway. Haven't quite drawn it in the right place. That's 35G going down there. And I've got my person going down there at 70G. My angle here is 45, so this angle will be 45, this angle will be 45, this angle will be 45. We've got a coefficient between the ladder and the wall is 1/3 for the friction, so we're going to have friction. Ladders tend to go that way, so the friction will act up this way. Ladders don't often slide up the wall. I'm going to do friction. Actually, I'm going to give myself a different subscript. I'm going to make it easy because I'm going to have two frictions. So I'm going to call that wall. And we can do that, the reaction on the wall. Okay. And then we have got a reaction down here. We call that reaction on the ground. And then we've got friction on the ground. Because the ladder wants to slip this way, the friction will act that way. So we've got all the forces that are currently acting on our ladder. So if we just start off, at this stage you don't really know where to go. So just start off with the easy bits of the moments. There's always the resolving bits. So resolve vertically, we're going to get the reaction on the ground plus this reaction on the floor against these two weights. So we've got reaction ground plus not reaction floor, sorry. Friction on the wall is equal to 35G plus 70G. So there's the upward force, there's an upward force, there's the downward forces. Let's just simplify that a little bit to get 105G. Now, if we resolve, now this one, we've got horizontal forces. Now, it's got to be an limiting equilibrium, remember? So even these also, this is not often you resolve horizontally moments questions, but in this one we have got some horizontal forces. So FG must equal RW. Okay, in this. We also know from friction that Fg here will equal, I think there's one, mu is equal to half here, and mu is equal to 1/3 up here. So this Fg will equal a half Rg, and will equal Fw will equal 1/3 Rw. And we're still not done, because we still don't have anything to do with X. And that's the thing we need to find. So therefore, resolving didn't find X. That's given us a series of equations. Let's just take moments about. Now, it doesn't really matter whether you do it about A or you do it about B. Okay, because this is going to be our key equation. You've got Rg, which is at A, and you've got Fw, which is at B. So one of them will need to be eliminated. I'm going to do A, and I'm going to go clockwise. So clockwise, let's just do, I'm just going to do my clockwise forces. So I've got nothing here, because this is my pivot. So these two will be negated because the distance from the pivot is 0. Now this one is going to be, I should have drawn it slightly differently, it's 3.5 meters from the pivot. So I'm going to have 3.5 times, the force is going to be 35G, but the perpendicular component of that force is going to be, well, you can do it two ways. You can either do it sine 45 or cos 45. They're both exactly the same. I'm going to write sine 45 because that's what I've done in my previous answers when I've written this out. So remember, you've got to take the perpendicular component of the force to work out its moment. The bit that's going to cause this to turn is the bit that acts in perpendicular direction. Same here, so we're going to have this one, we don't know the distance, so we're going to have x times by 70g times by sine of 45. Then we're going to get to these two up here. And this is where I kept making mistakes. I kept forgetting the 7 because the distance from the pivot is 7. So I did 7 times, let's do RW. Now we only want the perpendicular component, and the perpendicular component again is going to be sine of 45. And similarly, if we do FW, actually because it's 45 degrees, again it's going to be minus 7 FW sine 45. And all these moments will add up to naught because we're in equilibrium. So let's just go back. So I'm just trying to scroll that back across so we can get that as much as we can. So notice these are both negative because they're both rotating this way. Okay, they're going to both cause it to rotate that way about our pivot, so therefore they're both negative. And what we can do to make life easier straight away is get rid of all these sine 45s. They all cancel, which is quite nice. So we've got an RW in here and we've got an FW we want to get rid of. Now this is going to be our key equation. We can see we've got an FW there. If we can change that RG somehow into an FW, which we probably can, so we know that RG equals FG equals RW, and we know that FW equals a third RW, so that might be how we come about that first. We want an RW, so let's try and get the RG and the FW. Okay, so the F into terms of RW. Okay, so let's do that first, and that will be then simpler to go to the next bit. So we know that RW, let's get a thinner pen, is equal to FG, which is equal to a half RG. Okay, RW equals FG is equal to a half RG. So therefore we know that RG will be equal to 2RW. So I can place that there with 2RW. Okay, we also know that FW is equal to a third RW. So we can now put this all in terms of RW, and then we've got a value for RW to go into here. So we get 2RW plus 1/3 RW equals 105G. So therefore RW will equal 45G. Putting this and this into this equation and then dividing through by 2.5 to get 45. Now we know that FW equals a half RW. Wait a minute. No, it doesn't. Equals a third. That should be a third. Okay, I've already done these calculations already, hence why I've got the right number here. But if you did this divided by 2.5, you wouldn't get the right answer. So we've got FW is equal to a third of this. That's why I knew I made a mistake. 15 over G. And then you can just substitute these two straight into here. So we can substitute those two values straight into here. And then we've only got one unknown left. So we got 3.5 times 35, and we've got x times 70. So we're going to get, that's going to be 122.5 G. We got another 70xg minus 7 times RW, so times 45G minus 7 times FW, 15G equals 0. And we can cancel out all the G's. And now all we got is one unknown, nice linear out, a bit of algebra to do, and we can find out that x is equal to 4.25 meters. Now that was easy because I'd done that before. When I did that thoroughly through the question the first time, I must confess it did take me practically the full 8 minutes to do the juggling of all the questions, to all the equations, to work out what would eliminate. Because normally when you do simultaneous equations, what makes them nice and easy is you probably have A, B, you have, say you've got 3 equations, you've got a function of A, B, you've got multiple, I know, we can have K's in here, and you've got something to do with A, B, and C here, and something to do with A, B, and C. And you can use these 2 equations to eliminate to C, and you can eliminate these 2 equations to get C, and then you get 2 equations in A and B, and it's really simple to just eliminate down. What made this one really hard, if you're wondering why it's so hard, is the fact you don't have every single variable in every single equation, so it doesn't become easy to reduce down. Okay, and you've got to be quite systematic, or try a few things out to work out what it is you're going to eliminate to get to your answer. That's what makes this one longer and more difficult. And also, it's what means that you need to be able to do the other questions really quickly and be able to do them in half the time, so you have time to figure out annoying questions like this. Because it's actually mathematically not very difficult, just annoying. Anyway, on that note, we'll finish this one here today.